Hello and welcome to another video from Berkshire Guitar Amplifier Repairs. Stuart Smith in the workshop as always. I'm not sure whether I'm happy or displeased at this latest job I've got. Someone phoned me up and said he was an audio recording engineer and he'd had a client from Japan who wanted to do some recording in analog. Everything's digital nowadays, as you know. Well, my background is in actually audio recording, and back in the day I used to do a lot of big orchestras and operas using 2-inch tape and 12 tracks, 24 tracks, Scullies, that sort of thing, all analog with racks of Dolby, noise reduction. Anyway, apparently there's a bit of a fad these days to go back to analog, and this chap here who bought this equipment to me is quite a respected audio engineer, and he's had these equipment in his garage for many years unused. And he's dragged it out and brought it over to me with a view to maybe resurrecting it and using it on an analog recording. Okay, well the problem is this stuff weighs an absolute ton. There's an 8-channel mixer, which I'll show you in a moment, which I can't even move, it's so heavy. And it took two of us maybe half an hour to just get it into the workshop using all kinds of levers, pulleys and trolleys. And there are some microphone preamplifiers, I believe. Now all this stuff is home brew. By that I mean it was made by, I think, a sort of well-respected enthusiast who was well known for making good analog valve microphone preamplifiers and mixers. I haven't even touched it yet, apart from to bring it into the workshop. So let's go and have a look at what's been delivered, and then we can start taking some of it out of the flight cases and seeing what on earth we're getting involved with here. Oh, Lord have mercy. What on earth have we got here? So we've got mains in and out, that's okay, all looks quite neat. 1987, that's useful, look, so that shows you how old it is. 34 years old. It's 2021 as I'm recording this, August. And here are the channel 2, channel 1. Anyway, my guess is that this is the input from the microphones here. 2 channels per. So we've got 3 valves per channel here. That's quite a lot of valves, given that there are 2 amplifying elements in each one of these. You've got 6 stages of amplification for a microphone. I would have thought you could have done that in 2 valves, but anyway, there you go. Not sure really. Alright, well I think we'll just pull this, we'll pull this top unit and get it up on the bench, or maybe on this trolley, and have a look. I want to have a look what's inside this. Is it a can of worms, or is it beautifully done? Is it something we can work with, or is it just going to be a nightmare? Okay, moment of truth. You're seeing this as I am. I haven't taken the lid off here yet. What am I expecting here? Well, they're nice cases. They've been professionally silk screened. I would imagine we'd see a very neat job inside here. Maybe a homemade printed circuit board and some fairly decent wiring. I'd be surprised if it's a lash up in here. Of course, the other thing is we've got no schematics at all, so that is a big problem. It won't be very complicated. It'll be 3 ECC83s with a power supply and some transformers. Right, here we go. Right, okay, pretty much exactly as I expected. I'll take the camera off the stand and you can have a look. Right, so here we are inside. Very nice. Very professionally done, as I would have expected really. So we have, you can see immediately that it's fairly symmetrical here. So here's one channel, look, here, and here's the other channel, and this is almost certainly power supply here. This is the mains transformer, some little bridge rectifier there, a couple more diodes there. This is probably the HT, This is the smoothing, all nicely stuck together with compound. We've no idea of the condition of those capacitors. Ooh, see, this is the problem. See that bulge there? That is a problematic capacitor there. However, I tell you what I am liking, I can immediately see that the bottom panel comes off as well, which means that we can change some components if we have to. We have some, now what are these? These are, yeah, these are capacitors too. Very nice can capacitors. I've never seen those before, they're lovely. These I suspect are transformers, I would guess. These things here. And then we've got a couple of probably output transformers here. So these are probably, I'm only guessing here, my guess is these are the microphone matching transformers coming in. Right, so I would be loath to turn this on with this bulging capacitor there. So we need to change that one. The rest look okay from what you can tell, which is not very much. But don't forget it's 35 years old now. A little bit of burning on the board there I don't like. These power resistors also have been stood off because they obviously take a lot of heat, but they still burn the board. So whilst we've got the other panel off, we'll have a look at that, I think. Not a lot more to say about that. I think if I changed that capacitor there, I might just, you know, temporarily tack something in, and then we can power it up on the variac and see basically if we get any signal. Put a signal into it, see if we get any signal out, see if it's distorted, if it's noisy, make sure the gain functions all work. Yeah, it may all spring to life. I'm not saying anything here that will make me think, ooh, don't like the look of this. They've got ECC 83s in. These are just a whole load of ECC 83s. Golden Dragon brand, made in China. Well, I've no idea what those are, but anyway, there you go. So that's that really. I think I want to have a word with the client and ask him how much he wants to spend per module to get these going before I start getting too involved. But anyway, we've opened it up, we've had a look. It's all quite professionally done, and yeah, no reason really why it shouldn't power up and work, with the exception of these smoothing capacitors here. Hopefully they'll be okay, and of course we've got these great big cans here and some more here. There are smoothing capacitors all over the place on this amp. Look, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There are 20 electrolytics on this. Here we are, bottom side, which is great because we've got access to everything. And as I said, homemade printed circuit board. He obviously laid this out himself with a pen, drawing on a piece of transparent material, then making the printed circuit board himself. Hasn't even used any tape on this. Some burning around here where those power resistors are. We probably want to tidy that up a bit. I don't know, it might be alright. And then we can very easily change that capacitor if we want to. So the only problem with this amp is if something's wrong with it. In other words, you know, one channel doesn't work or something. We don't have a schematic, and we can spend a huge amount of time trying to sort this out. But on the same side of things, there's not a lot to go wrong with it. I imagine the valves are okay. I guess we could probably test them, but I doubt this has had much use, this piece of equipment. I bet it hasn't had more than a handful of hours of use. Alright, well that's it. I want to have a word with the customer and see what kind of budget he's got for this, and then we can take it from there. Right, I've had a word with the client about money, basically, because, you know, as soon as I start getting involved in this, the clock starts ticking. I've noticed, by the way, also that this switch here is, you know, broken, so we need to put a new switch in there. So we need to check this all out very thoroughly. But bottom line is, money is kind of no object. These are worth a small fortune each, apparently. maybe up to £10,000 each. So that's great. It means I can proceed with with confidence and carry on without worrying too much about counting the pennies. Right, so I've had a little think about this. What I think I'm going to do, I've got 4 of these. I'm going to do a quick assessment of each one and then write a label and stick it on here. Preamp 1, bulging 220 microfarad capacitor, broken front panel switch and whatever, anything else I can see, and then assess them all. And I'm hoping that maybe one of them will look fine. All the switches will look fine. There won't be any bulging capacitors, and maybe we could power that one up and see if we can get that working, because I'll feel a lot more confident having a working, functioning unit with which to compare any possible faults. That's the plan. Hope you approve. So I'm going to write a little label for this one, put the covers back on, and then move on to the second one. Okay, here's the second preamp. And the first thing I notice is that instead of that bulging cap that we had here, which was 4,700 microfarads at 63 volts, 2 other ones have been put in. Can't read the value immediately, so I wonder if he had trouble with that, and replaced those. A couple more hot resistors there. These have been getting hot again. All these caps, kind of, as far as you can tell, are okay. And it's exactly the same deal as before, with the exception of this proud valve here. Can you see how much that one sticks out compared to those? I have no idea what's going on there. What is this? That's a Golden Dragon E82cc. That's an ECC82. Pretty sure the other one has an ECC83 in it. So we've got a bit of a strange, and of course, bearing in mind there are 2 channels. Oh yes, there's an ECC82 there as well. But this one's bigger. Very strange. It's just a bigger version. So I'm going to need to check the valves to see if they're consistently, ECC82s or 81s. This is ECC83, 83, 83, 83, 82, 82. So that's what seems to be the complement here. Front switches, these are very vulnerable to getting knocked, which is why that one was broken on the other amp. Those are okay. That's okay. And that's okay. Good. Those feel alright. Yuck, this has something on it, like foam. I wonder if that's from the... that's from the flight case, I reckon. That foam there, that's a shame. I might be able to get that off, but it's kind of well on there. Around the back, same thing. Yeah, all looks fine. There's a voltage selector here. We have to be very careful that that is in the right position. 240 volts. And yeah, okay, well, let's take the bottom off. Won't be anything to see, but I just want to do a full inspection of each one of these to look for obvious stuff. So as things stand, that's interesting that these upgraded the bridge rectifier on this one too. The other bridge rectifier was quite a little one, so I might upgrade the bridge rectifier on all of them. I think it's probably a 2 amp rectifier, whereas the other one I'm pretty sure was a 1 amp. I might also think about this arrangement here. I don't like this red hot burning resistors here. I'll have a little think about what to do there to improve things. This is all assuming it works. So this is actually a candidate for a working amp. Let's get the bottom off and have a look underneath. Well, it's a case of nothing to see here. Pretty identical to the previous one, as you might expect. Nothing looks too horrendous there. Yeah. Right, so this is a candidate for a working amp. I'm going to label this up as no obvious faults, might be okay. Then we'll move on to the third one. Okay, here we go, preamplifier number 3. and interesting to note, less burning on the board, so maybe this amplifier hasn't been used very much. It has the, I think, 2 amp rectifier, it might be 5 amp that. Anyway, much more meatier rectifier than preamp 1. And look, yet another iteration of this capacitor here. We haven't had the same capacitor twice here. This is 1000 microfarads at 63 volts. So that's interesting. Everything else looks pretty much exactly the same. The valves are ECC82 on the outsides here. And look, these are not even Golden Dragon or whatever. We've got a whole mixture here. We've got Teardown, Golden Dragon, I don't know what this is even, DPS or something. I'm going to be testing all of these valves. I would never design a microphone preamplifier with valves. Why would you? They're noisy and distorted. Transistors are much better. But audiophiles are what they are, and valves have a certain mystique and warmth and hint of raspberry and taste of blackcurrant and all that stuff. So once again, front panel switches, these are, as I say, very vulnerable, these, to being knocked. That's okay. That's okay. That's okay. And that's okay. Good. And these all feel good. So here we have another candidate. And maybe the best candidate yet for one that might just power up and work okay. I'm starting to already formulate ideas about, you know, what to do here. We definitely need a high power bridge in here, and these look higher power than in the other amps. These are, I think they're 3 watts these. I might even consider changing those to 5 watt. Yeah, this has got fairly hot as well. So and it stood off the board, look, which means that you know, there are 2 in parallel there to take the power. So what's going on there? Why have we put 2 watt resistors in parallel to give you 4 watt? I'd be much happier with a decent 5 watt resistor in there. Everything else looks good though, so again, this might power up. Let's take the bottom off, just because I'm going to do a thorough inspection. That's the first job, but I don't expect to see anything exciting underneath. Oh well, nothing to see here as before. This is preamp 3 underside, and yeah, it all looks pretty much the same as everything else, so I don't think we need to worry too much about this. Again, you know, sort of strange motley. That's got a bit of masking tape on it, which someone's written something on there, and of course the masking tape's burned on. Weird. I'm kind of up for changing all of these valves if we can, because already we've got this kind of strange selection of valves. We haven't even got a proper set of carefully selected Golden Dragon Chinese valves, whatever they are. Okay, on to the final preamp, which is number 4. Here we are on preamp 4, and yet another iteration. We haven't had 2 the same so far. So I immediately noticed they've upgraded, was what I was going to do, upgraded these resistors, but it's not nice this. This is a very bad piece of work, the way these are flapping around in the breeze here. This will come desoldered at the bottom here. This really needs a better solution. This has got the 2 or 5 amp bridge rectifier. It's also been modified. There's an extra toroidal transformer on here producing another voltage for reasons we do not know, going on to this little bit of Vera board here with a, what is that chip there? 7.4, not sure what that is. Might need to look that up. No idea what's going on here. This will probably be a transistor, might be a voltage regulator. God knows what's going on here. But this is in place of where the 4700 63 volt capacitor was. Some of these connections here go off up to here, and there's some more. There's another board in here with some chips on it, and seems to go off to this connector here, which isn't on the back of some of the other amps. This mains, I guess that's a mains connection coming in, and I don't know what this is. No idea. Nope, never seen anything like that before. So no idea on this. I might have to ask the customer what he makes of this. Ooh, oh god. Right, well we've got all this gubbins here as well. Look. Yeah, yuck. I do not like this at all. This amp. This is a sort of homebrew gubbins here, all tacked on with bits of Vero board and soldered on. Horrible. Absolutely horrible. No idea what it's doing either. So that's a bit of an issue, I'm afraid. Pity. I would have liked all these to be, you know, pretty much the same. So different knobs on this one as well. Switches feel okay. This is the chap. Tim de Paravicini is the chap who designed this. He's dead apparently, he died. I know nothing about his company or him, but maybe he's extremely well respected, I don't know. Pity that. I'm a bit sort of fed up about that. You know, a bit of cardboard glued on the top here to act as insulation. A right lash up this is. No idea what that's for, and of course we will never be able to find out. So I think all we could probably do with this amp is, if we get some of the others working, again just power it up and see if we stick a microphone in, we get the same sort of signal out we might expect on the others, and if the volume all works and everything, and don't even worry about what all this gubbins is. You know, it could be anything. If it works as a microphone preamplifier. Oh, look, there's a phono socket bolted on the side there as well, which goes off, you know, to one of these boards. So Lord alone knows what they've done there. And again, look, a motley selection of valves here. We have a Teardown. Again, a couple of the Golden Dragons. What's this thing? Telefunken. So there's no rhyme or reason to having these valves here. They're not special, they're not ultra low noise. As far as I can see, these are just standard ECC82s and ECC83s. As I say, if I can find some low noise versions, we might slot them in. There's something going on here. This wasn't on the previous boards either, these two power resistors. So this is my least favourite, one of the four. Right, well we've looked at all four. I'll box them back up, and then I won't do it now, it's quite late here. I will power up the best one of the bunch and see if we can get a signal through it. I think that's the next thing. Okay, I'm getting ready for the power up of the best of the units. This is the one I assessed as being the most likely to function. Looks the newest, has the least burning and stuff on the boards, has a decent capacitor in here, a decent bridge rectifier. So I've got it hooked up as follows. First of all, we're on the variac over here, so I can wind up the power. Next I have my input signal is actually literally, I'm just going to use a microphone for the moment just to see if anything comes through when I speak into it. I'll get cleverer later with signals and that sort of stuff. And then on the output, I've unbalanced the output by shorting pins 2 and 1 together, and I've got the scope on it, and I'm just hoping to see some signal on the scope when I shout into the microphone. That's the plan. A little bit of an update on the valves. I think I remember saying that it was a bit of a motley selection. I had a word with a customer, and apparently the designer of this amp was never overly bothered about audiophile quality valves or low noise floors or anything. He pretty much bunged in anything that he had in the stock box apparently, so we're not going to worry either. I will be testing all the valves. We'll see if we can get this going first of all, and then I will be testing all the valves with my valve tester and replacing any that are worn. I fully expect them all to be okay actually. That's the plan. Let's have a go. I will turn this onto variac as opposed to bypass, I will turn the variac down. I haven't had this on yet. You're seeing this exactly as I am seeing it. I'll turn it on. This voltage and current meter doesn't display anything until we get a little bit of voltage coming in like that. Look, so we've got 37 volts AC coming in now and no current being drawn. So that's the situation, and I'm going to put the first thing I want to do is to put the scope on ×1. At the moment I've got it on ×10, so that'll make it a bit more sensitive. And what should we have? I don't know, half a volt per division or something should be okay. There won't be anything yet, of course. We haven't even got enough to keep the heaters going. What I'm really doing is watching for any silly currents being drawn. So I think let's go up to 100 volts. There's no current at all being drawn, nothing worth writing home about. This won't draw much current anyway, this thing. It's only preamplifiers. We've got a fair few heaters here, I suppose, but they won't draw anything dramatic. Valves don't seem to... oh, I suppose there's an on-off switch. Oh yes, we haven't got the power switch on. Okay, I'd forgotten about that. Right, as you were, let's wind this back down again and turn the thing on, I think. There we go. Okay, that's a bit better. Just turned on the power. Right, so again, 41 volts and nothing much in the current department. Let's bring it up to 100. There we go. Any lights coming on? That on-off light is extremely dead. Okay. No sign of any heaters or sign of any warmth yet. Okay, alright, well let's bring it up a bit more. Is that lamp a lit light? Oh yes, the lamp is now glowing dimly. Alright, that's good. So no dramatic currents are being drawn. It all looks fairly good. I'd like to be feeling these valves getting a bit warm. I'm reasonably confident to bring this up to full power actually, so we'll just put in the full power there. Front lights on. That's good. Phantom power is off, I believe. Up, I would believe, would be off, but who can tell? Input attenuator. I guess we'll have that off. I don't know what's happening there. Well, I can see some glowing in the valves. That's good. You can see that too. So the valves are glowing. I suppose we've got signal, have we? Oh, whoa! Look at that. Ooh, our heels are alive with the sound of music. Yeah. Well, this actually seems to be working. Ooh, that's amazing. Well, that's good. I was hoping we'd get one. I mean, they may all work, of course, but I was hoping we'd get one that we could use as a test. Now, these volume controls here are stepped, so I'm going to turn that up full. I think we're on this top one, but I'll turn up the bottom one just in case. Has that made a difference in sensitivity? Oh yes, look. Ooh, much more sensitive. Ooh. Wow, that's absolutely amazing. Let's just have a look at the noise. I'm going to put the mic down. I've actually turned the microphone off. And let's just go down to sort of 10 millivolts. Yeah, it's a fairly noisy old thing, isn't it? I mean, this is typical of valve gear, I'm afraid. Got all this shash all over everything. I mean, we're down at 20 millivolts, but there's a good 20 millivolts of noise there. High frequency, some high frequency noise on there actually. Wonder why. That is quite high frequency, so you won't hear that. Hum. That's 5 millivolts. There's a bit of hum on there, not much. Great. Well, I think I'll just try the other channel to see if that's working. Okay, here we are. I've just swapped the inputs and outputs to channel 2. There's the scope, and whoo, and there's the microphone. This is wonderful. It's actually working perfectly. How awesome is that? Woo. Good. Well, actually, I call that a result. Okay, I want to make a couple of measurements now. I want to measure the voltage, the DC voltage across these power resistors here, and find out the value of those power resistors, and also what's going on here with these two 2-watt resistors together to double up on the power, and they're looking a little bit hot. I want to find out what the voltage is across there as well, and then I can work out what power these resistors are dissipating, and we can decide if we want to upgrade them. I'm not wildly keen on this flapping about in the breeze idea here, unsupported resistors. You know, probably okay. And I want to test all of the valves. It's a bit purist of me to do that if the thing's working, but I want to see. I want to make sure that we haven't got a lot of worn valves in here. So that is the next step. Okay, this is the problem with not having a schematic, of course, on something like this. I'm not quite sure what's going on here, but basically what I've done, excuse a bit of a rough sketch, we've got a 23 volts or so AC winding on the transformer, and that's coming into this arrangement here where you've got 4 4.7 ohm resistors, 3 watts, effectively in parallel. I'll show you where they are in a moment. Well, 4.7 plus 4.7 is about 9, that's about 9. 9 in parallel with 9 is 4.7, so basically you've got a 4.7 ohm resistor between here and here. And they've done this to distribute the power. They've had problems with various iterations of this, and they've just kept doubling up on the resistors to distribute the power. That results in 19 volts AC across the bridge rectifier, which results in 19 volts or 20 volts DC across the output. Now they've got 3 2,500 2,200 microfarad 63 volt caps here to do the smoothing, and something I'd never seen before, they have these power resistors. They're about 1 watt, 2R2 2.2 ohm resistors in the negatives of these. I'm not quite sure why that's there. Then that goes off to ground. So a couple of things I'm not sure about. Why do they want 20 volts DC? Doesn't seem a useful voltage for this amp. There's a separate HT winding which I've discovered, which produces a couple of 100 volts DC, which is fine. That's what I expect to feed the tubes. We need to get some phantom power somewhere, and I seem to remember that was 48 volts, but that might be derived separately. Don't know what this 20 volts is, can't immediately find out what's going on. No schematic. Anyway, we probably don't need to worry too much about what it's doing, but I am worried about this area here, so let me show you on the board. Now all 4 of these preamps are different. Basically, my view is he's had trouble with this section and just kept on messing around with it to get it right. This is the best of the bunch. So here are these little 2.2 ohm resistors that are in the negatives of these smoothing capacitors, and we have 2 4.7 ohms on the top, and if I turn it upside down, we've got another 2 there tacked along the bottom, and he's done that to distribute the power. Now, why do we have a 4.7 ohm resistor there? Well, I don't know. There's no reason for it, so my guess is that he had a transformer, a mains transformer, which was readily available. He obviously didn't have these wound for him, and it had a 23 volt AC winding, which was too high, and he only wanted 19 volts or whatever it is, I don't know why, and so he's using these as a dropper resistors to get the AC voltage down such that the DC voltage is lower too. That's my only possible idea for this. Now, you can see that, maybe you can't, but certainly on some of the others, these are getting very hot. By the way, when I turned it on, these were too hot to touch. They weren't, you know, stupidly hot, but they're too hot to touch. There's a fair bit of heat being generated here. And also you can see there's a certain amount of kind of burning around the board here where the bridge rectifier's got hot. It's a bit of a naff arrangement, this. It's got all the signs of being jerry-rigged to solve a problem. I would much prefer to have something like a 4.7 ohm 10 watt resistor bolted to the side here, and then just get rid of all this lot and do that. Well, I don't know whether to do that or not, to be honest with you. Still thinking about it, but let's see what these resistors are supposed to be coping with. Okay, well, imagine this is a single 4.7 ohm resistor. Let's see what that has to cope with. And it's dropping about 4 volts across it. So what's the power through that resistor? Well, it's given by V squared over R, so we've got 4 volts, so 4 times 4 is 16, we don't need to use a calculator for that. V squared divided by R, which is 4.7. We've got about 3.5 watts going through all 4 of those resistors. So let's just say roughly a watt on each resistor. And these are 3 watt resistors, so they can cope with the power, and that feels like about 1 watt when I touch that. It's, you know, quite, you can't touch it, it's too hot. So they're well rated, but when you've got 1 watt going through 4 resistors, you've got 4 watts of dissipation there. That's quite a lot of heat energy going out, and I don't like these floating around here. That's really poor practice. As they vibrate as you move, the solder joints just come undone underneath. So I'm really kind of tempted to see if I can get a power resistor in there. Here's my dummy load for my testing amps, and this is what a 10 watt resistor looks like. So it's kind of that long. We'd struggle to get one in there actually. Well, we probably might get one sideways. We'd certainly get one on the back here, so maybe that's the place for it, to put the resistor down there. And of course this would dissipate the power nicely. A couple of leads going down to there, job done. That bridge rectifier is up to it. Still gets quite warm though. So this is producing 20 volts for who knows what purposes. The other winding I can't immediately locate is a heater winding, so could this be something to do with the heater supply? I bet you anything you like that actually, the more I think about this, the more I think I know what's going on here. He wouldn't want an AC heater supply on these valves because it would give a certain amount of hum. It's much cleaner to have a DC supply on the heaters. So 20 volts, 1, 2, 3, is it? Is he putting 3 of these heaters in series with each other? I bet you that's what he's doing. Here's what I think's happening here. Let me get a pen and find one. So I think what's happening here is we have 3 heaters, 1, 2, 3, with, it says 19 volts, 20 volts DC, but you know, well, let's say 20, I don't know, maybe I'll measure it a bit more carefully. They do all need 6.3, so 3 6.3s are 18, 19 volts pretty much. That's not far off, is it? 19 volts across there, 3 heaters in parallel, and then the other 3 valves are over here with another 3, and of course you need a fair old bit of current here, which is why you need the big bridge rectifier to do those. That's what he's doing. I'm convinced of it. I can do some tests on the valves to see if that's true, and that's a nice low noise solution. And of course, if you're stuck with this is probably a 24 volt winding on this transformer with standard 24 volt winding. I was measuring it under load, so it's probably being reduced. I bet he's got an off-the-shelf transformer, 24 volt AC winding. That's too much because it would give 24 volts here, which would give 7.3 volts on each of the heaters. Too much. And that's what he's done. I'm absolutely convinced of that. Let me do a couple of checks on the valves to see if 3 of the heaters are in series, and then I'll get back to you to confirm that. Yes, I've just checked the valve printer circuit board, and that's exactly what he's done. So that makes sense to me now. I couldn't work out why he would want to drop a couple of volts here, and why did he want 20 volts AC? Bit of a weird voltage, that. 24 volts DC, I beg your pardon. I still don't know what these little 2K2 resistors are, but I don't know. Not worried about that. Right, so at least we know what's going on here. Don't like this arrangement very much. I'm going to consider changing it, and I'm going to get a 10 watt resistor now from my box and see how big it is. Okay, there we go. Actually, that is a 4 ohm resistor. So that will go nicely on there, for example, and also I can get a drill in there to drill those 2 holes. It won't go in there. It'll go in there diagonally, but that's a bit shonky. Yeah. Okay, now to finish up on the theory, if you remember, this is the equivalent circuit of what we've got inside here. We've got the AC coming in, 23, 24 volts. It's being dropped by this 4.7 ohm 4 watt resistor effectively. And then out of here comes our 18 volts or so DC. And we have several capacitors in this position here. Now this bridge rectifier here, what kind of current bridge rectifier do we need here? Well, we're dropping about 4 volts across that resistor there. Therefore there's about an amp going through this resistor here. Therefore there's about an amp going through the bridge rectifier, give or take. So at the very least we need a 1 amp bridge rectifier. Now I noticed in one of the first ones we took the lid off, we had one of these little jobbies, excuse the capacitor, tacked on, just ignore that, and here's this little round bridge rectifier. This is a 1 amp bridge rectifier. So in at least one of these units he has put a 1 amp bridge rectifier where the bridge rectifier is pulling 1 amp. Well, that's exceptionally poor design, and of course he's fallen foul of it, because we can see that in later iterations he has swapped this bridge rectifier for a larger one, something a bit like this. I think this is a 3 amp bridge rectifier. So I am going to do a modification to these preamps, because this is just a mess here. I'm going to put a 10 watt resistor in place of that and bolt it to the chassis, and I'm going to make sure that each of the units has at least this 3 amp rectifier. And when I touch the rectifier in this one, which is this 3 amp one, it's pretty warm. So I'm going to make a little metal heatsink, just a little bent piece of aluminium dump like that, nothing special, bolted on there, and that will give a considerable amount of cooling. It probably actually doesn't need it, but let's do that anyway. So that's the modification I'm going to do, and that will sort out that problem once and for all. Now, since we're sorting out the power supply problems on this preamp, I'm also not happy about these 2 watt resistors here. They are quite badly burned, and you can see there's oxidization on the legs. Again, they've been doubled up here to get some more power out of them. I've got a meter on them. It's hard to read them because the bands are burned, but I think that's 8.2 something, 820 ohms, 8K2, 82K, 820K, and I've got a meter across them, and it's reading 36K. So I think they're probably 820K resistors in parallel, giving about 40K across them. And what are they doing? Well, that's quite a drop down. There's another winding on the mains transformer coming in here to feed this lot, and another set of bridge rectifiers. There's another effectively bridge rectifier made of 4 diodes there, and then these dropper resistors, and then I think we've probably got a couple of Zener diodes here. I really need to check what they are. My guess is that these resistors here are dropping quite a high voltage down to feed these Zeners. smoothed by this capacitor, and it's probably, if I had to guess, the phantom power. So what I want to do now is to turn the amp on, have a little measure around here. I might try and see if I can read what those Zener diodes are, and then measure the voltage across these resistors here, and that will tell us what power that they are consuming. And we may need to do a little bit of improvement here too, because it's not brilliant, is it that? Not very good design at all. Well, surprise surprise, those are 24 volt Zeners, 2 of them in series, giving 48 volts for the phantom power. I will eventually need to check what this capacitor is. At 63 volts, this one, so just about okay. I would probably put a 100 volt capacitor in there, and the voltage across these resistors is, wait for it, nearly 300 volts. So there's a second HT winding coming off here, which is being rectified by these diodes down here to produce a very high DC voltage of about 325 volts or something, and it's being dropped down by those resistors to produce 48 volts DC for the phantom power. A completely naff way of doing it. Let's work out what those 2 resistors there are dissipating heat wise, but just for the moment I'm convinced that what's happened here is either got a job lot of transformers, or he's found an off-the-shelf transformer and get a sensible price. It hasn't got the windings he wants. It hasn't got a 50 volt winding to give him the 48 volts phantom power. It hasn't got the right winding for the heaters of these valves. He's had to cobble something together like that. So this guy might have been good at designing audio preamplifiers, but he's absolutely flipping useless at designing power supplies. I can tell you that just by looking at this. Absolute mess this is. Anyway, let's see what power those are dissipating. Remember, they've got 294 volts across them. So let's get the calculator out and do the sums. Well, power is given by V squared over R, so it's 294 squared times 294 is 86,000 divided by the resistance, which is 40k if you remember roughly. 40, 1, 2, 3, just roughly. And we've got over 2 watts, look. So although those 2 watt resistors are just about up to it, they've got a watt going through each of them. For a 2 watt resistor you might think, well, that's okay. And they've survived, of course they have. They've got just over a watt going through each of them, and they're a 2 watt resistor. But that, you see, is tight for me. I wouldn't do that. I would put a proper 5 watt resistor in there. And what a terrible way of deriving the supply anyway from a 335 volt HT line. Absolutely terrible. And just a quick aside, I've just powered the amplifier down and stuck my finger on those resistors, and they're way too hot to touch. Half a second and I'm yelping in pain. So they are getting very hot. Well, whilst we're having fun doing some calculations, let's also double check that those Zener diodes there, which look a bit skinny to me, are of the correct wattage. Well, to do that, we know we've got 295 volts roughly, call it 300, across a 40k resistor. So our current down there is I equals V upon R, so it's 300 volts divided by 40,000, but we'll leave the 1,000 off and call it milliamps. Look, divided by 40 is 7.5 milliamps. So it's about 7 milliamps going through those Zeners. That doesn't sound bad to me actually. What's the power dissipation? Well, power is volts times amps, and so we've got 7.5 milliamps times volts, which is 24 volts across one of the Zeners. So that's a dissipation in milliwatts through the Zener. Move the decimal point 3 to the left, 1, 2, 3, 0.2 watts, 0.2 watts, which is fine. So those diodes are correctly rated. Don't need to worry about those. Now I've just realised I've made a little bit of a mistake. This resistor here, which I picked out of my box, of course isn't 10 watts. These are 100 watt resistors, so these are absolutely massive. So we don't need anything that big in there. I'll probably go for these 25 watt resistors, so they're much more sensibly sized look compared to that, so that's good. And I'm kind of tempted to get two resistors here, to put a resistor there and a resistor there, one of 39k to do the phantom power, and one of what it said 4.7 ohms to do the drop down for the heaters of the valves. Okay, I have failed to find any high resistance 25 watt resistors like this. They all tend to be lowish. You get 1k and that kind of thing, but to get 40k or 39k, I haven't been able to find them. I'm not saying you can't get them, but I've had a good old look on the internet. So plan B is to use some of these which you can get. These are 5 watt cement resistors, and I can get those quite easily. So I've ordered some 82k's of those, and I'm going to put 2 in parallel in a solution that I've yet to devise, because obviously this is quite a big resistor. So we may end up with something on here, I don't know exactly. I want to come up with something clever for that, but I think I'll wait until I've got all the resistors in and then have a little think about that. I'm just going through now and testing all the 8 valves in the amp. I've done about 4 of them and found one faulty one which I've replaced. And just to show you how I do that, I just use this simple orange tester to test preamp valves. I test power valves in a different way. And you select the valve here, ECC83, press start, and off it goes, and it just cycles through like this. It takes a while, maybe a couple of minutes. I'll probably just fade out here, and it's coming to the end of its testing now. It's just winding down, and that's come up with a good, and this is telling you the gain of each of the 2 halves. So ideally they should be the same number, and the further apart these two are, the more mismatched the 2 halves of the valve, which is perfectly adequate, perfectly close enough. And that's another good valve. So I'm just ploughing through now and testing all of the valves. Now, one other thing I want to do with these amplifiers is to make sure that they are all approximately the same gain as each other. I haven't been asked to calibrate them particularly. We don't really need them all to be exactly the same, but I think it would be useful to have a setup whereby, with this at the 12 o'clock position and the attenuator out, which is down by the way, what input voltage is required to give a given output voltage, and we can make a note of that, and then we can just go through all of the amplifiers and make sure that they're all roughly about the same. That with the attenuator out and this on 12 o'clock, it gives the same sort of output for a given input. So let's do that now. So over on the scope, we've got a bit too much signal here. I'm just going to bring the input. I've got a signal generator. I'm just going to bring this down until this comes down to, it's just a bit arbitrary what I've chosen, 2 volts peak to peak. There we go. So that's our test amount. Now all we need to do is to measure the output of the signal generator using the scope, and then that will tell you what the gain is of this. So let's do that now. So because the input signal will be quite small, I'm going to measure with the attenuator in, which is this switch up, rather surprisingly. So that's attenuating the input by 10 dB, and this is going to be at 12 o'clock, and then we can compare one amplifier with another to make sure that they give approximately the same gain as each other. We don't need to calibrate these exactly, but we do want to know that they're all working approximately the same. So we have the attenuator in, we're at 12 o'clock on the switched volume control, and I'm going to go for 5 volts peak to peak on the output. That's quite large, but I want a reasonably large input signal, because it's quite hard to measure a very tiny input signal. So to get 5 volts peak to peak, let's see what we're doing. 1, 2, 3, 4, 5. Well, that's not far off actually. Just bring it down a tiny bit. There we go. So that's 5 volts peak to peak on the output. And now let's see what the input is from the signal generator. And to do that, I'll connect the scope up to that, and we can measure that. Then we'll be in a position to work out the gain of this device. Okay, I've got the scope connected now to the output of the signal generator, and you can see we're measuring approximately 200 millivolts peak to peak input. Now don't forget we've got a 10 dB attenuator in as well between the input signal and the amplifier, but it doesn't matter. I just want to get a constant set of test conditions so that we can compare one amplifier with another. So this is our set of standard test conditions we're going to use for all the amplifiers. It's arbitrary, but it doesn't matter because all we're doing is comparing one with another to make sure they're all about the same. So we've got the input of 200 millivolts peak to peak at 1 kilohertz. Output is 5 volts peak to peak, so there's a gain of 25 there. And we've got the 10 dB pad in as well, so there's much more gain than that going on. And we have the attenuator in and the volume at 12 o'clock, and of course we've got much more gain if we wind up the volume control. So there's plenty of gain on this amplifier. So I'm just now going to test the second channel to make sure that it performs the same as this one. Before we move to channel 2, I'm just going to do a frequency sweep on this channel 2 to make sure it's got a decent frequency range, and to do that we'll go down to, let me see, so we'll go down to 100 Hertz, which is down here. Bring our time base in a bit, and we've got 1, 2, 3, 4, 5 volts still. Look, we can go down a little bit lower. That's 15 Hertz there. So it's got an excellent frequency response. Look, 1, 2, 3, 4, 5. That's completely flat. 10 Hertz, remarkable, very, very good frequency response. Let's go a bit higher now. Let's go up to 10 kilohertz. So here we are at 5 kilohertz, 10, still completely flat. Look, 5 divisions, and we'll go a bit higher to, that's actually 100 kilohertz, which is way too high. We'll come back down. Let's see where it starts rolling off. So that's 20 kilohertz there. Where are we? 1, 2, 3, 4. Yes, so there's a bit of a roll off. That's 20 kilohertz there. I'd have expected that to be flat up to 20 kilohertz, but it's not far down. It's certainly flat up to 15 kilohertz. So yeah, it rolls off a bit at 20k and rolls off a bit after that as we come up, look, to 40 kilohertz, 50 kilohertz. There we go. Anyway, it's got a fantastic frequency response. That's good. No one can hear 20 kilohertz anyway. Right, so now we'll go and do the same tests on the second preamplifier. So the controls are identical on the two amplifiers. I haven't touched the input level, may as well leave that exactly as it was for the first amplifier. And there we go, 1 kilohertz, and we've got 1, 2, 3, 4, 5 divisions. Identical gain on this one, that's very encouraging. And we'll go down in frequency, it's 100 hertz now. And 10 hertz, that's great, very good low frequency response. How does this one do at the high frequencies? That's 15 kilohertz and 20. So how's that doing? One, two, three, four. See, it's rolling off a bit at 20 kilohertz. So these two channels are absolutely identical, which is good. That's exactly what we want to be seeing. Excellent. Okay, an update. I've tested the other 3 of these units, and I did have a problem on one of those. There was a dry joint on a capacitor, which took me a while to sort out. I sorted that out, and now all the other 3 units are working, and they all give pretty much the same gain. I did have to change the odd valve or 2. I went through and tested all the valves, and I've changed the odd one. I think I've changed 4 valves so far in 3 units. Now we come on to the 4th unit. And if you remember, this is the unit which is absolutely chock full of all this gubbins. There's a whole horrible board on here with 40-pin chips, this tacky little bit of board put here. And I had a word with the customer. I didn't expect him to know, actually. I thought he might have just have inherited these and never taken the lids off, but he knew exactly what it was. Apparently the designer wanted to have a go at making an A to D output, so in other words a digital output, which I think comes out on one of these terminals here. So this is all A to D conversion. I mean, excuse me. So the customer wants me to strip all this out. So my plan of action on this amp is I want to see if I can get it going the same as the other amps were. In other words, will it pass the signal, and has it got the right sort of gain, and because none of that will be affected by this A to D stuff. And if that's working, we can then quite simply start to take out all this gubbins here. The only thing I'm slightly confused about is what happened to the capacitor that sits in here. If you remember, in all the other ones there's a, I think it's 2200 microfarad at 63 volts or something, for the phantom power, and also there's some diodes, some Xena diodes. So maybe this amp doesn't have phantom power, maybe they sacrificed the phantom power or got it somewhere else, I don't know exactly. So we may have to restore the phantom power on this too, but the first thing to do is let's see if it works. Okay, well unfortunately we've got a bit of an issue with this one. I'm in one of the channels. I've tried both channels. I'm in, I think, the second channel here, and I've got exactly the same 200 millivolts peak to peak going into the amp, but we've only got 1 volt peak to peak coming out compared with the 6 volts that we have had on all the other amps. And these front switches, attenuators, are in the same position as the others. I can turn this up, look, and I can get a fair old bit of gain, but I don't know why in this position where it says 0, strangely enough, that's the position I've been using too. I don't know why that is only giving 1 volt. And when I change the plugs over to the other one, like so, we have exactly the same 1 volt peak to peak. So it's all working, it's just that the gain is 1/6 of the gain on the others. This may be by design, there might be a reason for it, I just don't know. I might have a word with the customer to see if he knows what's gone on. I haven't tested the valves yet. I don't suspect the valves because basically the gain is identical on both sides of this amp, so I don't think that would be a valve problem. Yeah, well, the next thing to do is to test the valves, because I'm testing the valves on all of them, and that will be another little job out of the way, so I'll do that and then let you know what the result is. Okay, quick update. I tested all the ECC83s, all 4 of those, and they were all good. When I came to check the ECC82s, they both failed. When I looked at them, they are not in fact ECC82s, they're ECC85s. Not a valve I've ever come across. So I'm going to need to look into what that valve is. Has it been deliberately put in there? Is it a low gain version? I don't know what's going on here. So this is not the same as the others, and also I don't remember these 2 resistors hanging off the back board of the other 2 either, so I'm not quite sure what's going on there. And just a little aside, the mains input is upside down on this one compared to the others, so it's all a bit of a mess really. Anyway, let me see if I can find out some more information, and I've asked the customer to call me, he may know what's going on here. Okay, I've been on the interweb, and apparently an ECC85 is a reasonable substitute for a 12AT7, i.e. an ECC81, which is interesting. Although the heater is different, and you have to wire the heater differently compared to an ECC81. So I'm not quite sure why he has decided to use this valve instead of the ECC82, which he has used in the previous 3 of these that I've looked at. The ECC82 on these preamps is it's doing quite a lot of heavy lifting actually. It gets very hot compared to the others, and it's actually being used as effectively an output tube to drive the output transformer. So it's doing quite a lot of work on these amps. I'm not really quite sure about these ECC85s. I'll see if I can find some more information from the customer. Okay, I had a word with the customer. He wasn't really sure about that, although he did comment that the very high output of these amplifiers would be way too high for the A to D converter, so maybe it was padded down or something to bring the level down. Also, these switches here have been repurposed. They were the phantom power switch. It now seems to turn the output off. I'm not quite sure what it's doing. And they do go off to the A to D board here, so all in all, it's not going to be particularly easy to get this going, so I'm going to put it to one side for the moment until I've finished modifying all the other three, or six I should say, and then we can do a kind of A to B comparison and maybe try and get this one back to the same state as the others. Okay, well, some of the parts have come in now, so we can make a start on just upgrading the components on this power supply side of things. They're all getting a little bit hot. And yeah, they're probably limp on, but it's not very nice, and we want to kind of make it a little bit better. These resistors here, as you can see, are very prone to vibration, and they'll come unsoldered eventually. So we've got a 4.7 ohm 25 watt resistor. I over specified this. I wanted a 10 watt, but I accidentally ordered a 25 watt, but it doesn't matter. This is going to go on here, and that's going to replace these two resistors in parallel. They differ from unit to unit, but this particular one has got two 2.2 ohm resistors in series, I beg your pardon, to produce 4.4 ohms or 4.7 ohms, which is what we've got. And so we're going to replace those by bolting that to the side there. I'm going to try and get a little heat sink on this bridge rectifier here, just a little, nothing fancy, just a little bit of bent aluminium, just to cool that down a bit. It's getting, you know, hot, not too hot to touch, but fairly hot. And then I want to replace these two 82k 2 watt resistors in parallel, giving 41k, with a couple of, what have I got here? I'm not sure what I've got here. Oh yes, I've got a couple of 82Ks 5 watts, and once again I'm going to try and get those up here somewhere in a way that I haven't really quite determined yet. If I'm honest, we might tackle that first, because that's the more difficult part of the job. Getting those on there like that will provide an excellent heatsink and completely cure this problem. You can see they have been getting pretty warm, those, so hot that you can hardly even read the legend on them. These are the dropper resistors to produce the 48 volts for the phantom power. Okay, well, let's make a start and work out how we're going to get these on the side here. Well, my first thought was that if I twist these two legs together like this and put them somehow vertically, then that bottom twisted pair can go pretty much to the terminal that this one's going to here. So we can connect that straight to there, just leaving the top terminal, the top twisted pair, to come off via a piece of wire down to where this went to. So we're going to try and mount them vertically that way. No idea how yet. Okay, well, my thought is to put these like this, then obviously I can connect that in at the bottom there, and we'll bring a wire from here down to the other terminal, which is down there. Well, here we are less than 10 minutes later, and this has gone off pretty solidly. I can just about get my nail in, but given another half an hour, that's going to be rock hard. This is great stuff, and needless to say, that's glued on there forever. Whilst it was drying, I also made that solder joint down there by putting a kind of loop of quite thick tinned copper wire around and soldering it on the underside of the board and then to here. So this is pretty mechanically sound anyway. Now all we need to do is to bring this wire down and get it into that hole there, which we'll do next, and that's job done on that. That's great, that's a fantastic solution. Right, there we go. I've brought a bit of tinned copper wire up from the board and across to there. It's all very mechanically sound, even if this came undone, which it never will. This is now quite mechanically secure here, so it won't flop around at all. So that's job done on that. I guess we ought to turn it on and make sure we've got 48 volts on the Zenas here. And also we can see how warm these get. I think that'll be quite interesting. Of course the epoxy to a certain extent is removing the heat sinking capacity of these resistors being against this metal. But anyway, we've more than doubled up on the power of these resistors. So I'm going to turn it on and see how warm these get. Okay, well, nothing straightforward with these amplifiers. When I turned it on, I had 37 volts across the two Zenas down the bottom there, and not 48 volts. So I thought, oh god, here we go. So anyway, what I've done is I've desoldered this and put the original two 82Ks on there, and I still get 37 volts on there. So now I'm looking and thinking, what's gone on here? Why are there two Zenas in series here? We've got the, I'll just disconnect this for a second. We've got the 24 volt Zena, and if you remember, maybe you do remember on one of the other preamps, we just had two 24 volt Zenas side by side to give 48 volts. Well, one of the 24 volts has been taken out on this one, and we've got this shonky arrangement of two Zenas in series, giving 37 volts here now. So what's going on there? Anyway, I think I'm tempted to take those two Zenas out and put a 24 volt Zena in there and bring this back up to 48 volts, because that, I believe, is what the phantom power should be. Yes, I've just checked again, and across the blue Zena there I've got 24 volts, which is what I'd expect, and across this two in series here I've got 11.6 volts or something. So God knows what's gone on there. I'm going to have a rootle around to see if I can find a 24 volt Zena. I couldn't find a 24 volt Zena, but I had plenty of 12 volt ones, so I'm going to put two 12 volts in series like this and replace these two series ones with these two. Right, so now I'm just going to leave this on. I've got 48 volts now on the phantom power. These are all nicely in, these power transistors. These are both nicely in, these power resistors. I'm just going to leave it on now for, I don't know, an hour or two really, and see how warm these 5 watt resistors get. And also I'd like to feel a little bit of warmth on the panel here, but of course with this epoxy putty may be slightly thermally insulating, as well as of course, you know, being a good glue. So let's see what happens. And whilst we're waiting for that to warm up, there's a chance to see how kind of burned these resistors are. No, they're okay, they're still measuring the right value, and they'll probably limp along, but I hate running power resistors at close to their maximum. I think 1 watt through a 3 watt resistor is the most you should go for. Maybe 2 watts through a 5 watt resistor, that sort of thing. Even that's going to get pretty darned hot. Okay, that's been on about an hour and it's warm to the touch, not hot, and I can leave my finger there. There's no observable heat transference to this panel, and that will be due to the insulating effects of the putty. So that's job done on that. They're absolutely fine. Much better solution than before. So now I'm going to try and put this 4.7 ohm resistor, I think I want to put it about here. The reason is I want to get the drill. I want to be able to get the drill in here, and this transformer's in the way. I don't want to be sort of trying to get a drill in here, which will be difficult. So I'm hoping I can get a drill in there. So I'm just going to mark this up and then see how we get on. I might just offer the drill up first of all and make sure to see where we can get to. Okay, no dice there. I couldn't get a drill in here past all this lot. You can see where I skidded on there. I did my best to drill. I centre popped it, but it just wouldn't take. The drill was coming in at too sharp an angle. So plan B is I'm going to put it on this face here, which will be fine. It's got to go to here anyway, so not too far, so we'll put it on there. Now of course I can drill from this side quite easily. Okay, I've pre-made up the leads for the power resistor, and I've put a couple of holes in the side, and using my handy little template which was required because this is the mirror image of that, and if you try to put this flat up against there and drill through, when you find you kind of put it on this side, it won't fit. So now I'm just going to nut and bolt this on, and I might put a little smear of heat sink compound along there, and then we can wire it in. Right, there we are, nicely bolted in. Little tiny smear of heat sink compound, not really needed. And now we're going to remove these two and just tack these wires on underneath, and that'll be job done on that. Then we can turn it on and see how warm this gets. I've chopped out those two 2.2 ohm resistors in series, giving 4.4 ohms, and put in that 4.7 ohm, and it's those purple wires there going under the board, which I've just soldered on those two terminals there. So now I'm going to turn it on, and then I'm going to decide whether I want to go to the trouble of taking this bridge rectifier out and putting some sort of heatsink on it. I'm going to leave this on for an hour or so. I want to see how warm this gets, do a double check on how warm this gets, and then put my finger on the bridge rectifier and see how warm that's getting. Then I can decide whether it's worth the hassle of taking that out. So let's do that. Okay, it's on and the valves are glowing at about the right level I would expect them to glow, which kind of means that this power supply here is working okay. Whilst it's warming up, I thought we'd check the phantom power, and to do that I'm just going in on pins 1 and actually, where is it? It's on the phantom power is across pins 2 and 3. As you can see, I've got 48 volts there. If I turn it off on this front panel switch, it's got a phantom power switch that goes down to nothing. And now let's do the same on the other channel. .48 volts, and then I'll do the other switch here. That one goes down to nothing. 48 volts, so the phantom power is good. That's just another little check. Now, assuming we don't need to put a heatsink on here, I mean, that is warm, almost too hot to touch. I can just about keep my finger on there, comfortably on there, not really hurting, but it's warm. And I can't feel anything on there at the moment, but it's only been on 10 minutes, so let's leave it on for a while and come back and see how we feel about it. Well, the idea for a heatsink is just to take a piece of aluminium and drill a hole where I've centre popped it there. That will be bolted on, and then we'll bend up the two ends like a couple of wings, and that will give it just a little bit of dissipation. I don't know if it's worth doing really. It doesn't take very long. The difficult thing is, of course, I've got to take the bridge rectifier out of the board. Not difficult, but that's just a bit more of a pain. I've got to take that out and then bolt the heatsink on and put it back on. So we'll see if we do that. I might just go ahead and make this up because it's only a 5-minute job, and I'm kind of hanging around waiting to see what the temperature of this does anyway. There you go, that's the sort of idea I had in mind. Just bolted a piece of metal firmly to there. I only had those kind of longish M4 bolts, but that doesn't matter because that's just extra thermal mass really, so that's good. I think I'm just going to go ahead and put this in, put a brand new bridge rectifier in. I've ordered them all up for this job anyway, and I'll go ahead and make up 4 of these and put them in. Nothing to lose. Not terribly pretty, but certainly does the job. Okay, an update after about an hour on. First thing to notice is that this epoxy putty has just come loose off there. I haven't even touched that, so there's no sticking power whatsoever for that putty. It doesn't stick. Not sure what it's for. Is it for fixing holes in exhaust pipes or something? I don't know, but it certainly isn't a glue. However, I'm quite pleased to see that this is actually very stable here, the way I've done this, so I can almost leave that alone. I might just put a little bit of hot melt glue there to hold that to there. So that's interesting. I've learned something there. I think my search continues for high temperature epoxy glue as opposed to epoxy putty. Right, the bridge rectifier here is almost too hot to touch. That's uncomfortable on the back of my hand there. That's quite hot. Also notice it's right next to this capacitor here. Very poor design again. I know I keep saying it. He seemed to be very good at the audio side. This is looking very nice over here. But when it came to power supplies, he obviously wasn't very good at all, because this bridge rectifier is actually heating up this capacitor here, which is very, very poor. And this will fail eventually. So I'm going to put the heatsink on there. And over on here, this is warm to the touch, but perfectly comfortable. And interestingly enough, this side panel is warm too. So this is doing its job in heat sinking this this resistor here. Yeah, that's warm. It's not. Yeah, you know what? I couldn't keep my thumb there much longer than I am. So this was a good move, putting this 25 watt resistor in compared to those ones that were hanging off inside there. So that was a great move. Right, I am going to go ahead now and change this bridge rectifier. I've made up 4 of them whilst I was waiting, so these are ready to go into the others, and I'll be interested to see what difference that makes temperature wise to that is uncomfortably hot. It won't make a huge difference, but it'll be enough. And there we go, that wasn't too difficult to put in. So there's a new one in there with its bit of heat sinking there. That'll make, you know, a fair few degrees difference. I would guess about 5 degrees C difference, which is significant. So I'm just going to leave this on again now for a while and see how hot that does get. I should be able to hold that heatsink quite comfortably without burning my hands. Okay, I tacked that in at the top with a bit of ordinary araldite because it's not getting stupidly hot, this, so that ordinary araldite will be fine. This is getting nice and warm here. When I put my hand on the side, that is warm. So that just shows you how much heat was being chucked out by those 2 resistors that are flapping around in the breeze there. I can put my thumb on it and it's warm to hot. I can leave my thumb on it for a while. This is interesting. So these 2 fins here are quite hot. You know, with my fingers, I couldn't leave my fingers there too long. Yeah, that's just about uncomfortable. So that shows you how much heat that bridge rectifier was chucking out. And this will be a much better arrangement here, and that'll make it last much longer. So I'm happy with that lot. I think we've got ourselves a template there. I've made myself up already 3 more bridge rectifiers, 3 more sets of resistors, and 3 more sets of power resistors ready to go into the other 3 amps. And I'm going to put the lid on this one and call this a finish. Call this one finished. So what I'm going to do now is modify the other 2 that were in quite good condition, if you remember. I won't obviously bore you with that lot, it'll just be a repeat process of this. And then I'm going to tackle that one which was giving out 1/6 of the input signal of this one, and we had to strip out all the gubbins, and I'm going to take a view on exactly what to do there in terms of removing all that stuff and trying to get it up to the same sort of spec as these. Right, it's been a few days since I last did anything on this, and we're on the 3rd preamp. I've completely modified a second one. On the 3rd one here, I've put the 4.7 ohm power resistor in, and that's all wired in. We still need to change the bridge rectifier there for my little arrangement here. We still need to put in the 82k resistors, and we need to change now. This particular preamp has a couple of faults with it. You can see we have a very bulgy capacitor here, so I'm not at all happy with that. I'm going to change that, and one of the switches, oh yes, this front one here, look, is broken. Very vulnerable, these sorts of switches. Not particularly easy to change this switch. You can see it's got a little cluster of stuff off the back there, so that's going to be an interesting little thing. And I bought a few replacement switches which will do the job, so we'll get into that. But the first thing I want to do is to change this capacitor, so I'll just desolder it from the other side, and then I've got this 2200 microfarad 63 volt Phillips capacitor we're going to try and put in somehow, somewhere. Okay, that's desoldered, and there it is taken out. Definitely bulgy, that. Probably still works, but not ideal. I think we'll chuck that. That's 4,700 at 63 volts. In my grab box I found a 12,000 at 63 volts. That's a heck of a big capacitor for 63 volts, but oh well, there it is. I'm sure that'll be fine, and we'll see now if we can get it in here somehow. It's not too dissimilar in size from the original, in fact very similar. So it should go right in with a bit of luck. Right, that's that capacitor put in there. A little bit of hot melt glue to hold it in place. Next I want to work out what's going on with the Zener diodes. If you remember, this is a 48 volt area here for the phantom power. And in the previous amps they had a couple of 2 watt resistors in parallel across here, whereas in this amp they've got this resistor coming from here in series with a much smaller wattage resistor, the total value of which seems to be about 20k as opposed to 40k. I'm just wondering what's going on there. No two of these preamps are the same. Anyway, I'll check that out. I just wanted to have a very quick word about phantom power because I realise that some people may not know what it is even. Without going into too much detail, it's basically a DC voltage, 48 volts, which is applied across the XLR sockets, and it allows capacitor microphones to be powered from the actual signal socket without taking a separate power supply to the capacitor microphones. Back in the old days they all had their great big separate box power supplies into which you plugged the mic and then took an XLR out of the box and into the mixer or whatever. But 48 volt phantom power allows you to power external equipment. It hardly needs any current, so we're only talking about the odd couple of milliamps here. And 48 volts is applied equally to pins 2 and 3. So there's 48 volts on pin 2 and 48 volts on pin 3. So there's no actual voltage across the signal twisted pair. No DC voltage across there. So anyway, that's how that works. I thought you'd like to know, just in case you weren't familiar with that. I've no idea why it's 48 volts. It's like all these things in electronics. Why do we have 4.7k resistors and 3.9k resistors and 6.3 amp fuses? I mean, most of it is lost in the mists of antiquity. Why not a 50 volt phantom power supply, for example? I don't know. Someone else watching this may. Right, so the next thing to do is work out what's going on here with these. Right, well, I don't really know what's gone on here. If you remember, we used to have, on the other preamps, we had 282k 2 watts in parallel, giving about 41k at 4 watts. On this one, they've got an 18k 1 watt, I reckon, in series with a 22k, I don't know how many watts that is. It might possibly be 5 watts. Very weird arrangement, all up onto this tag here. Whether that was an attempt to reduce the power or something, I don't know. It's a bit of a mess, really. So anyway, we're going to revert to the same thing we've done on the others, which is to put these two 82Ks in parallel with each other. Right, I'm going to have a go at this switch here. It's quite complicated. I've made the best sketch I can of what's going on. I think this is just like a 10 dB cut switch, so it's awfully complicated for what it's doing. But anyway, I've labelled up these cables with a bit of tape, red and green, and they're stereo cables, so they've each got 2 inners and a screen. Screens are joined together. I'm going to take the switch out now and have a go at replacing it. Okay, I've got the switch out, but of course nothing's straightforward, is it? You will notice that this switch has a very long threaded section here to allow it to get through this very thick front panel. My switch doesn't, so that will not go through the panel, and also the diameter of that hole there is smaller than the diameter of that hole. So that switch is no good at all. So I was just thinking of trying to order another one when I thought I would try and straighten the actuator on this switch, and I managed, using a pair of pliers and some judicious force, to straighten this so that now it actually works. Look, and this actuator no longer kind of rotates around inside. So it's not perfectly straight, but certainly good enough. So now we can put this switch back. I think I'll just check quickly that it's working, but I'm fairly sure it is. And we can put this switch back, so that's good. It means I don't have to take all these resistors off as well. Bit of a mess this, isn't it, really? I mean, as I've mentioned a couple of times now, the designer seemed very, very keen on the audio side of this, to the extent that he's made a switch 10 dB, not 9.9 dB or 10.1 dB, but exactly 10 dB with all these series resistors getting the resistance exactly right. Who cares if it's 10 dB or 9 or 11? It makes no difference whatsoever. It's only basically a cut to reduce the gain. So he's gone to all that trouble of doing all that, but as we've commented a couple of times now, messed up the power supply design. Oh well, there you go. I'll put the switch back now. Right, I've finished everything now on this third preamp, or third pair of preamps. The 10 dB switch works perfectly after I bent it straight, and everything else is okay. None of this gets too warm, and this is all good to go. So the only thing left now is to look at the fourth set of preamps, which, if you remember, were the ones that were absolutely full of extra gubbins. And also, by the way, the output of that fourth set of preamps is much lower than the output of these preamps, so I'm not quite sure what's going on there. Anyway, that's the next job, to try to remove some of that stuff and see if we can retain a functioning preamp. Well, one thing I've noticed immediately is that the phantom power switches here have been repurposed. I don't know what they're doing. This goes off along here, these brown wires. This has got screen cable going to this A to D board here. And also this is where the two Xeno diodes and smoothing capacitor were for the phantom power, and they've bunged this bit of Veriboard in here. So this does not have phantom power. I think what I'm going to do is I'm just going to go ahead and take all this out. I'm just going to disconnect everything from here, this board here, take out this toroidal transformer, take out this little subboard here, and then see what we've got left. It will be fairly easy to reinstate, I think, the phantom power, because of course we have some other preamps which we can copy the wiring of, so I think that's what I'm going to go ahead and do. It's a bit hard to know where to start here, actually. There's so much stuff in here, and it's not very easy to get out either. I might have to take this front panel off, I think. But anyway, I'm going to make a start, if I can, on this toroidal transformer. Okay, I've got rid of most of the gubbins, as you will see, and I think I'm going to leave this little board in here. It's not doing any harm in there. Quite difficult to get out, and it's got these huge connectors on the other side of it. And if I take those out, I'm going to leave big holes in the chassis. And I think I'll just leave these connectors on. They're not doing anything. The board's completely disconnected, so I think I'll leave it at that. This is a bit of a weird cable here. I've checked on the other amps, and this is ground, and that is in fact grounded to the main ground on the other amps via a thin wire which comes from sort of typically here over across to here. It's all the same As you can see, this is connected around here to here, so I don't know why I use this great big thing. Now I'm just going to shorten that and bring that from there to there, and leave it at that. So then, having done that, I think I might fire it up and make sure it works. There you go. I think you'll agree that's a little bit neater than that great big trailing cable. Right, I think let's just power it up and see if it works. Right, we're all plugged up into the first channel. I've got about 200 or 300 millivolts going in, and we've got 4 volts or so, 1, 2, 3 volts peak to peak coming out. This one seems to be lower gain than the others, as I said, but the gain control here does actually work quite well. Goes down, turns up, and it will go up quite high gain. There's plenty of gain here. Right, let's just check the frequency response. Let's go up to 1K, and that's about 1K, and that's about 20K there. So it's down a bit at 20K. 20K compared to I don't know, maybe not too far off. I turned the gain down, of course, on the front. That's why. No, that's quite good. So that's well, wait, that's 100 hertz there. 2 divisions, and that's 10 kilohertz. 2 divisions, and 20 kilohertz. 2 divisions. So we're good there. Let's check the other channel. So this is the second channel, 100 hertz, 1 kilohertz, 10 kilohertz, 20 kilohertz, I beg your pardon. So that was 200 hertz, 2 kilohertz and 20 kilohertz. And we'll just go back down to the lower frequencies again and bring that down a bit. And that's 100 hertz, that's 50 hertz. That's actually 10 hertz, so it's amazingly good low frequency response. That's good. And the front panel gain, just check that. Turn up the frequency a bit, I think it's a bit. There we go. So front panel gain, plenty there. Volts of the stuff. Okay, so great, so it's all working, having removed all the gubbins, which is great. Now, I've had a think about this. I'm not willing to get involved in finding out why the designer has put an ECC85 in here and here, rather than the ECC82, or why this amplifier is lower gain than the others. If the customer wants me to do this as a special, I might quote for it as a separate job, but it means tracing all the printed circuit board, things going through it component by component by component to try and find out what's gone on. He's obviously done it for a reason. I'm suggesting we leave well enough alone. There's tons of gain on here. The only thing is that this particular pair of amps wouldn't match the other 3, in the sense that if you set this to midway and the others to midway, they'd have different gains. But I don't think that matters. I mean, this is used in a microphone situation. You plug a microphone in and you turn up the gain until you've got enough level on it. So they don't have to match in that sense. Right, so I'm going to leave it at that. That's my executive decision for the night. And all that remains for us to do now on this final amplifier is to put in, just going to turn this off, is to put in these components that we did for the other one. If you remember, the bridge rectifier with a heatsink, the twisted pair of resistors, and the high watt resistor there, and of course we have to restore the 48 volts phantom power, and to do that I'm just going to have to copy what's happened on a previous amp. But before I do that, I'll get the Xeno diodes in, I'll get a smoothing capacitor in, I'll get 48 volts here, and then we'll see how we get it off to the sockets, see how that works. Good, I'm not going to do that now. In fact, I'm just off on my holidays. I'm going to St Ives in Cornwall, so I'm going to go there for a week, and then when I return we will do these last bits and we can sign off all 4 pairs of amplifiers. Just before I disappear, I thought you might like to see all the junk we took out of this amp. It's a flipping nightmare. There's all this lot here. A little bit of Vero board with a crystal tacked on top there. These resistors tacked across this integrated circuit. Ugh, yuck. I mean, look at it. A bit of tag board here with some components hanging off it. And it's just, ugh. Underneath that we've got mods and tracks joined together and bits of wire, and God, I can't believe this ever worked. And then I don't know what half this stuff is, to be honest with you. This is a 74F04N, not sure what that is. That's a regulator there, but another bit of Vero board, look, all tacked together. This I think was a phono socket line input or something. And I don't know if you noticed during my Zen bit how this was soldered onto the chassis via a little lump of solder. Yuck! Toroidal transformer. I should probably just bin this. I can't be bothered to work out what the connections of it are. And loads of other bits of wire plus the board we left inside. Happy days, eh? Okay, well I'll see you after the holes. Right, I finished the modifications to this final amp. I've put heatsink on the bridge rectifier and a new bridge rectifier, 224 volt Zenas, our arrangement of these 2 power resistors here which feed those Zenas, and here is the Zena smoothing capacitor, one I happen to have in stock, so I put that on a capacitor clip. And we will also see that we have our 49 volts, or should be 48 volts, low load phantom power. So now the final thing to do is to work out how to connect up these 2 phantom power switches, which just switches the phantom power off and on, to these input output XLRs here. So I'm just going to have a look at an existing one to see how they've done that. It's normally a couple of 6K8 resistors which buffer the phantom power onto those pins. No idea why 6K8, but there you go. I don't have any in stock. I've ordered a couple of 2 watt 6K8s, and you can see if I go over onto this other one here, here we go. So you can see here is the switches here, and they've got this 6K8 resistor here, and then these 2 wires go off snaking around here somewhere. I just need to find out where they take those wires and how they get the phantom power over to here. But we're getting quite close now. Well, nothing's easy. This one we're working on now, which had all the extra junk in, and we're trying to restore the phantom power on, is completely different from the others. These 2 transformers are close together here, look, with the tag board here, and on all the other 3 we have this big distance between the transformers and the tag board here. I think it's probably wired the same, but wouldn't it have been nice if all 4 had been the same and I could just literally copy the wiring from here across to here? But no, that would be far too easy. So let me try and see if I can work out what's happening here. Right, I'm going to take this a step at a time, and the first thing is to get the 48 volts from the phantom power Zena circuit, and it's on this red and black here, and it goes through here and it goes up. The red positive goes to the switches and the black goes off here to the tag board. So I'm going to duplicate the same thing on this one here, and get that stage done to start with. Right, I have got the 48 volts coming into the switch, into both switches at the moment. I then went to connect the negative, and on this one the negative is connected to the negative of these two screened leads here, which are the inputs, the microphone inputs. And the two screens are, you can't see very well I guess, but they are two screens go onto the same tag, which is what you'd expect, and then this negative wire here goes to that tag. So I thought, okay, I'll do that on this one, but over on this one these two screen leads are separated, they don't go to the same tag, and the screens amazingly are not short circuit, so that screen is not a short circuit with that one, which is absolutely ridiculous. So not really sure what to do here. I'm kind of tempted just to link this screen to that screen there and take the negative to there. Now we need to find out where the positive goes, and okay, yes, I'll need to have a look at that in a moment. Struggling a bit here. This positive 48 volts here goes to a tag here, which is connected to a thick bundle of wires here, which goes off to the transformer, whereas the tag next to it, just on the other side of it, is the positive pin 3 of the output. And there's about 5 ohms difference between that pin and that pin, so I'm not quite sure why he's taken the 48 volts to some tapping on the winding of this transformer. And none of that would matter, of course, but of course when we come over to here it's not even remotely like that. We haven't got this thick bundle of wires. The doesn't even look like the transformers are maybe the same transformers, so it's a completely different situation. You know, something's been nagging away at me ever since I looked at this phantom power. I recalled that you normally need two 6K8 resistors, and I looked up the circuit, and indeed that is exactly what you do need. So here's the standard phantom power circuit. You put 48 volts in here via two 6K8 resistors onto pins 2 and 3. The signal is on pins 2 and 3, by the way, the balanced signal from the microphone. So that results in 48 volts DC being on pin 2 and pin 3. You don't really want an imbalance between those two. And then you pick off the signal exactly how you would normally do if these resistors weren't here. Just literally take off pins 2 and 3 into the microphone amplifier, and out that goes to wherever the signal's going. So you need these two resistors here to do this. Right, now you will notice of course that on these ones here, he's only used one resistor, but that resistor is not going to either pins 2 or 3 of this circuit. So I think that one resistor is probably going to some center tap on a microphone input transformer or something, which has the same effect of putting 48 volts DC on there and there. Now we can't do that with the new one because we don't seem to have that arrangement. I don't know what that tap is that he's used on the other one. It doesn't seem to be on this transformer. So I think we're going to have to put 4 resistors. I've decided now not to link those grounds there. Let's just keep these preamps kind of separate. And so we're going to come off the switch with 2 6K8 resistors, one to pin 2 and one to pin 3 on here. And then from the same position on the switch, the same 48 volts switched, another 6K8 resistor down to this one and a 6K8 resistor down to this one. And that will give us 2 kind of separate phantom power circuits. I don't know what the implications of linking that screen are with that one. He separated them for a reason. Maybe we should stick with that. Right, so that's the plan. Well, a slight change of plan, just having thought about it for 10 minutes. Of course we are going to have to link those two screens, those two grounds, because we have a common 0 volts from the 48 volt phantom power. And we're going to want to take that 0 volts there to pin one of the XLRs, and we're going to need to take exactly the same ground 48 volts to pin one of the other of the XLRs, which of course is exactly the same as linking the two pin 1s together. So I don't really see any harm maybe in linking those two grounds. Now I've also had to think about why he's got a 2-watt resistor here. Again, didn't seem right to me, and I've done a few sums over here, look. So basically the maximum power that this 6K8 resistor can take is if 48 volts develops across it and you've got 0 volts here, which would be useless to any kind of equipment you're trying to power anyway. But that would be the absolute worst case. So the maximum power this can ever dissipate is if this pin is short-circuited, or that one's short-circuited of course in the case of that resistor, and that's 0 volts, that's 48 volts. We've got 48 volts across a 6K8 resistor. Power is given by V squared over R. 48 squared over 6,800 is 0.33 watts. I don't know why I've got V there, I meant watts there, 0.33 watts. And in reality it's going to be much less than that, because this equipment needs 12 volts or 24 volts to run it. Usually it's normally the preamplifier inside a microphone, inside a condenser microphone, and it's not going to be 0 volts there, it's going to be 12 minimum, so our voltage is reduced and so our power is greatly reduced as it goes 5V squared. So in other words, an ordinary small resistor is perfectly okay here. We don't need these stonking great big 2-watt resistors. Another weird kind of aspect of the design of this amp. It just makes me wonder, well, I suppose it kind of makes me wonder about his abilities, to be totally honest with you, with those power supply errors and the choice of a resistor which is 10 times too large in wattage for what we need. Anyway, there you go. Right, so that's the plan. We'll get some, I've got some 6K8 resistors, ordinary ones in stock, and what I think I'll do is I might just attach them on this tag board here. So put the 2 resistors out, twist them at the other ends together, and then take that off to the switch, and then do the same for the other one. Right, there you go, there are the 2 resistor pairs made up, ready to go in onto the tag boards. Right, there's the first pair of 6K8 resistors in, with the wire going across to the switch. Here's the other 48 volts coming in, which I will now take down to a similar pair of resistors on the bottom of the tag board. So I'll just finish that off and then we're ready for testing. Right, I put that other resistor pair in and all seems to be okay. So I'm on pins 1 and 2 of this particular channel, and you can see we've got 49 volts there, and the switch on the front, if I flick it, turns that off. That's good. We should also have the same between pins 1 and 3, I'm sure we will. There we go, yep. Now let's check the same on here. So between pins 1 and 2 we have 48 volts, 49 volts, and the switch works. And between pins 1 and 3 we should have the same, and we do. So I reckon that's got phantom power. So this is all completed now, this particular one, and the only thing I'm going to do is to check it with a microphone that requires phantom power, just to make sure everything's okay. And I'll just give it another test as well, since I've linked those 2 screens. I can't imagine that would do anything. But anyway, there we go. So that's job completed on this. Assuming that's alright, I won't bother reporting back to you, and we can call this one a wrap. It's been quite a long project. Well, there you go, a very interesting project, I think. Quite long, I've been quite a few weeks on it, gradually going through all 8 of the preamps and getting them up to scratch. So that's a wrap on that one. Hope you enjoyed it. What I don't know whether I've mentioned to you, but this actually goes with a valve mixer, an 8-channel mixer, which is the next thing I'm going to look at for this customer. And this is a huge beast of a mixer. I can hardly even move it. So I'm going to make a separate video about that, and hopefully we'll be able to get the mixer going as well. Right, that's it from me. Thanks as always for watching. I'll catch you on the next video.